End behavior is fairly simple. Try not to overcomplicate it. We'll fill out this chart. If you still don't know what's going on, we've got plenty of examples on the next page, and then we will even practice in class. So let's see what this chart is telling us. So this chart is talking about highest powers being even or odd, and then the leading coefficient being positive or negative. So let's say we have the equation x squared plus 2x. The highest power is even because it's 2. So we would look in the first column, and the leading coefficient is 1 because there's a secret 1 here. So we would look in the first row. So x squared plus 2x would have the end behavior that matches this first graph. Let's say we had the equation negative 6x to the fifth plus 4x to the fourth minus x. Highest power in this case is odd because it is a 5. So we would be looking in the last column, and there's a negative leading coefficient because this 6 is negative. So we would be looking in the second row. So it would have the same end behavior as this bottom graph. Again, end behavior is fairly simple. Try not to overthink it. I've just zoomed in on this chart, so it makes it a little bit easier. So end behavior just describes where the arrows are pointing. That's it. So usually we talk about what happens as x gets smaller first. So as x gets smaller and we go to the left, that's headed towards negative infinity. As we follow x to the right, those values are going towards positive infinity. And then the arrows of your graph can point one or two ways. Up to when y is positive infinity, or down to when y is negative infinity. So go ahead and sketch yourself this graph. So this is an example of a graph where the power would be even and there would be a positive leading coefficient. So here's how we write end behavior. As x arrow negative infinity. How we would read that is as x goes to negative infinity. So as your graph goes left, you're going to tell me what happens to the arrow. So f of x goes to, so the graph goes to, and if it's pointing up, it's positive infinity. If it's going down, it's negative infinity. So one more time, as x is going left, which way is your arrow pointing? Up towards positive infinity. That's it. Then we have to talk about the right-hand side of your graph. So as x goes to positive infinity, so if we follow the graph to the right, as the graph is going right, which way does your arrow point? Towards positive infinity. So f of x goes to positive infinity. That's it. Like I said, we usually talk about as x goes towards negative infinity first, because that's to the left, and then as x goes to positive infinity second, because that's when x goes to the right. Let's take a look at the next column. So the next column would be a highest power is odd, still with a leading positive coefficient. Again, as x goes to the left, it goes towards negative infinity. As x goes to the right, it goes towards positive infinity. And then your f of x value can either go down towards negative infinity or up towards positive infinity. And go ahead and sketch that graph. So, same setup. We're going to talk about as x goes to negative infinity first. So as x goes to negative infinity, so over here, as the graph goes left, which way does your arrow point? f of x points down towards negative infinity. Let's talk about the right-hand side of the graph. As x goes to positive infinity, so as the graph moves right, your arrow, f of x, points towards positive infinity. Hopefully that doesn't seem too confusing. Like I said, on the next example page, it might come more clear to you. So this is the bottom row. I've just brought the headers down from the top of the table so I can see them in the presentation. So go ahead and label your negative infinities and your positive infinities, just like we did up top. So now we're going to talk about when the highest power is even, but we have a negative leading coefficient. Go ahead and sketch the graph. Same setup as last time. We're going to talk about the left-hand side first. So as your graph goes left, how does your arrow point? F of x goes to or points towards. In this case, the left-hand side is down towards negative infinity. Let's talk about the right-hand side. So as x goes to positive infinity, so as we follow this graph to the right towards positive infinity, the arrow points down to negative infinity. Last one. Highest power is odd, still having a negative leading coefficient. Go ahead and sketch this graph. We're going to talk about the left-hand side first. So as x goes to negative infinity, so if we follow this graph left, which way does your arrow point? F of x goes to or points towards positive infinity. Last thing, we're going to talk about the right-hand side as x goes to positive infinity. So here on the right, as the graph goes to the right, your arrow or your f of x points towards negative infinity. So here's what my paper looks like. And I did notice, so adding underneath, is that the even powers, the arrows point in the same direction. So in this first column, it doesn't matter if the leading coefficient is positive or negative, the arrows point in the same direction, whether they're up or down. If the highest power is odd, the arrows point in opposite directions. So one goes up and one goes down. The only thing that decides that is if the leading coefficient is positive or negative. So make sure your table is all filled out, and underneath you have added even powers, arrows point in the same direction, and odd powers, arrows point in the opposite direction. The examples page this time is not going to be a handout. We're just going to write them down. As we go through these, you should be putting these equations into your calculator. You're going to want to follow along with the calculator because it builds your muscle memory and it will help you be able to apply and use this calculator skills later. If you need to, you might want to write down the calculator buttons that you're pressing so you know what to do in the future. So here's what my page looks like. It's just 7 problems. Make sure you have the title, Key Features of Functions, Part 3, page 6. Describe the end behavior of the following functions. If you want to, you can copy all the problems down now and fill them in as we go, or write them down and fill them in as we go through the example problem.